You have previously learned about regression equations in other courses, such as Algebra 2. Some of you may have even taken AP Statistics. So I'm going to do a little bit of an overview of regression, and then I'm going to talk about residuals and storing your models in your y equals, which may be different for some of you. So if you've already learned some of this, you can continue on your own without watching the video, but there are some minor changes that I'm going to make for some of you as well. So what is a regression model or a regression equation? A regression equation is used to predict data sets. It's a line of best fit or a curve of best fit. Remember that it's not going to be exact. It's not going to be perfect. So it's not going to go through every single data point, but it's going to have the best approximation. So some are going to be above the line, some are going to be below the line, or some are going to be above the curve and some are going to be below the curve, because we're not just talking about linear regression, we're talking about all different types of regression. So what regression models are we going to be using in this course? We're going to be using a bunch of them, but one particular one that I want to point out is the difference in linear regression. So we're used to linear regression being choice 4. We are going to be using linear regression as choice 8. For those of you that have taken AP Stats, you would be familiar with that one. We are definitely going to be using quadratic, cubic, exponential. We'll probably see some sinusoidal as well, but anything from 5 to C in your calculate menu for the stat option is going to be what we will be using this year, from 5 through C. And then how are we going to know if a regression model is appropriate? This is something that is probably going to be new for most of you. We're going to be talking about residual plots on a very basic level, not to the level of AP Stats, but in general, a residual plot is going to be used for us to determine if the model is appropriate or if we should be running a different regression. So the steps for calculating a regression equation are in your notes. Everything is going to be the same that you're used to. Choice 5, or step 5 rather, is going to be to choose your appropriate regression model. So if we're choosing exponential, it would be 0. If we're choosing quadratic, it would be 5. And remember now, linear would be 8. What's going to be new for some of you is going to be these last few steps here, which is going to be storing our equation in Y1. So I'm going to show you how to do that as we go through the example. If you go to the first example, we're talking about a cup of coffee. It says if a cup of coffee is left on a countertop, it will cool off slowly. The following table shows the temperature variation of a cup of coffee left sitting for 50 minutes. What I'd like you to do right now is pause the video and enter all of your information into L1 and L2, so that way you can go through the rest of this process with me. I'm not going to review that in the video, but you're going to hit Stat Edit and enter all that information. And then when you're ready, don't run your regression model yet. We're going to do that together, so hit play, and I'm going to show you how to do it and store your values from the equation into your y equals. So hopefully by now you already have everything in L1 and L2 like I have here. We're going to go back to stat. We're going to go to calculate. We're choosing exponential regression, which is choice 0. L1 and L2, you know, for your X list and your Y list. What's going to be different is I now want to store my equation in y equals. I don't want to have to retype these values with the coefficients into y equals because a couple of reasons. One, it takes a while. It could be tedious. 2, if you're rounding, it may throw things off, and we never want to round until our last step in an equation, and that's very important in this course. So we want to just store it there so we don't have to worry about it. So in that store regression equation area where you see my cursor blinking, I'm now going to enter Y1. And the shortcut to do that is alpha, trace, and here are all your options. We're going to go with Y1 because I have nothing in there. So please make sure actually you go to your y equals and clear it out. You don't want anything in there. And then I'm going to go down to calculate as I normally would. So I am going to copy and paste this all onto my worksheet. And before I do that, I'm actually going to go back to my calculator and just show you right here. If I click y equals, you can now see my equation in there. So I don't need to worry about it. It's already stored for me. If I were to hit zoom 6, because that's always where we want to start, I'm not going to see it because it has larger coefficient values. But if I hit zoom fit or zoom out, we would probably be able to see it. Might need to zoom out even a little bit more here. There you go. So you can see that equation, your regression equation for exponential graphed, it's stored in your y equals. I am going to go back to zoom 6 because we always want our basic window just so I have it. So back on my worksheet over here, I am going to write my equation. So you always want to copy all of this information down just so you have it on your screen. And then they want us to round, in this case, to the nearest hundredth. So remember that nearest hundredth is 2 places. So my equation is going to be y equals 167.06 times 0.99 to the x power. Part B, based on the data. So if I'm looking at data, this is going to be my table or my scatter plot. We'll talk about those in a minute. Based on the data, what was the initial temperature of the coffee? So that's at time, which is my x, equals 0. So based on the data, it is going to be 176.81 degrees Fahrenheit. Then it says, based on the equation, what was the expected? Notice how I'm now talking about expected or predicted. I'm no longer talking about the actual temperature of the coffee. So I'm going to substitute in x equals 0, or you may already know and remember that in an exponential equation, this is your initial. Or you can substitute x equals 0 and evaluate. It's up to you. So the data told me it was 176.81. The equation tells me my temperature is 167.06 degrees Fahrenheit. And now it wants us to explain why it's different from the data. So the temperature in the equation is different from the data because it is a predicted value. Part C. Use your equation to find f of 18 to the nearest hundredth and explain its meaning. So remember, what's inside a set of parentheses here is always going to be my input value, which is going to be my x value. So since I already have to explain, let's just talk about that for a second. If I go back up here, these are my x's and these are my y's. So x represents the time sitting on the counter. So I'll find f of 18 in 1 second, but I want to do my explanation. After sitting on the counter for 18 minutes, because that's what my x value is, the temperature of the coffee was, and when we find it, we're going to do that. So I could substitute in, if I wanted to, x equals 18 into the equation, but let's go back to our calculator and remember that this was saved in my y equals. So I can actually right now go to my table by hitting second graph, and I can scroll down to 18, or if you want to, I can go to my table set, so second window, and I can start my table at 18, and it just jumps quickly for me instead of me having to scroll through. So when x is 18, y is 134.33. So 134.33 degrees Fahrenheit. And I am actually going to just click and drag this into here so that way you guys can see and keep this in your notes if you'd like to, because you're going to want to justify. So I'm just going to circle this and put it over here since I'm running out of room, and circle that value. Part D now says using your equation to find x to the nearest integer. Remember, integer is like a whole number, but it has positives and negatives, such that f of x equals 118. So x is what I'm looking for. This is like saying y equals 118. So let's go back to our table for a second because I do have to interpret. 118 is a y value, which means it's a temperature. So I'm going to do my interpretation first. The coffee was 118 degrees Fahrenheit when it was sitting on the table for blank minutes. And I'm going to solve and find that right now. So I'm going to use my equation. So I had y equals 167.06 times 0.99 to the x power. And I'm setting y equal to 118. So we're going to solve this algebraically, but remember you could of course use your calculator. I'm going to start by dividing both sides by my initial value because I need to isolate my base. So in my calculator, I'm going to go to the home screen, second quit, and I'm going to do 118 divided by 167.06. Here's my value. You don't want to delete that. You don't want to do anything with it. If you want, you could store it even, but we're just going to leave it like this for right now. You could also, remember, hit math, enter, enter, and it'll give it to you as a fraction. If you prefer to work with fractions, totally up to you. Just pick what works for you in the calculator. So I have 5,900 over 8353. Is equal to 0.99 to the x power. And now I am going to turn this into a log. So I'm going to keep my base of 0.99, use my fraction, and I'm going to evaluate this log on my calculator. So alpha window 5, 0.99 is my base. I'm going to choose my answer from up above, so using second negative sign, or you could scroll up and hit select it and hit enter to copy and paste. Here's my value, 34.592, and so on. And that's equal to x, but they wanted it to the nearest integer. So that means 35. And there's my interpretation. The coffee was 118 degrees Fahrenheit when it was sitting on the table for 35 minutes. Okay, now we're going to sketch a scatter plot, and I'm going to run through the steps, but they are listed on your calculator here. I already have my data entered into L1 and L2. I'm going to turn my stat plot on. So in my calculator, I'm going to go to second y equals. I'm going to choose plot 1, so I'm going to hit enter to select that. Right now it's off, which is why that's highlighted. I'm going to turn it on by hitting enter. I have a scatter plot chosen here. These are just some other graphs that you would use in AP Stats or things like that. I have L1 and L2 listed, so I'm good to go. And then I'm going to hit zoom 9. I do want to, actually we can leave it like this so you can see it. So we already have our regression equation stored in Y1. So right now you're seeing not only the scatter plot, but you're seeing your model as well and how it's kind of fit to that. If you wanted to, you could go back to Y equals and hit enter and unselect the equal sign without deleting that whole entire thing. And then I can go back to my graph and now you would just see your scatter plot. So just take a minute to pause the video and sketch this onto your worksheet. I am going to click and drag. Of course, you could do the same thing if you would like as well and put that there on my worksheet. Now let's talk about residuals. So residuals, I said we're going to be using a residual plot to determine a goodness of fit or if a regression model is appropriate. So what is a residual in general? A residual is the difference between the actual Y value, which comes from our scatter plot, and the predicted Y value, which comes from the regression equation line or curve. And it is the vertical distance from the actual plotted point to the point on the regression line. If a scatter plot and the regression equation agree on a Y value, meaning there's no difference, a residual is going to be 0. So in order to find a residual, if you had to do it by hand, it would be actual minus predicted. Always talking about Y values here. And a residual plot is going to be a scatter plot once again, but instead of my L1 and my L2, my X list and my Y list, it's going to be my X and my residual. And it's going to be listed as your vertical axes is a residual. And I'm going to show you how to do that with the steps on the calculator as well. So I want to use our calculator to find our residuals here. So this, and graph a picture of it. So here are all of your steps. I'm going to run through it with you, but they are here if you need them. So I'm going to go back to my calculator. I'm going to go back to the stat edit screen and I'm going to leave L1 and L2. I don't want to change that. I want to work with L3. So I'm going to scroll up to the L3 heading, that column, see how it's highlighted here? And I'm going to hit second stat, which is going to bring up all of my list options, L1, L2, L3, and so on. I want to use 7, which is the residual. So at the bottom, it says L3 equals residual, and I'm going to hit enter, and it has now calculated all of your residuals for you. So what I'd like you to do right now is take a minute, pause the video, copy all of those residuals down into your worksheet so that way you have it. Okay, let's talk about a residual plot as well. So we know how to do a scatter plot now. We just reviewed that earlier in the video. In order to do a residual plot, instead of L1 and L2, I just want to change it to L3. So I'm going to go back to my stat plots, second Y equals. My stat plot is currently on. I still want a scatter plot, but I'm going to change my Y list down here to L3 because remember, L3 we just used to calculate all of our residuals. So second 3, we'll put the L3 there. You want to change the color or the marking, go right ahead, but you don't need to. I'm going to go back to my zoom 9 because that is always going to be our go-to with stats. So in general, we go to zoom 6. When we're working with trig, we go to zoom 7. And we're working with scatter plots, we go to zoom 9. Take a minute, pause the video, copy down your scatter plot, or I am going to click and drag this onto my worksheet here. So feel free to do the same so that way you have it in your notes. Okay, so hopefully by now you have your residuals copied down from your calculator and entered into your table. You have your scatter plot or your residual plot shown here. Because I covered up my axes, I am just going to label this as the residuals. And lastly, what does a residual plot show? So I briefly talked about the fact that a residual plot for us is going to be used to determine if our model was appropriate or goodness of fit. So in general, pattern Bad, random, good. A residual plot is going to show how accurate our regression model was. The regression model is appropriate or good when the plots are random around the axes. We want them to be both above and below the x-axis, and we don't want a pattern. The regression model is not appropriate when the plots follow a pattern such as resembling a curve or a wave. And our residual should be relatively small in size because remember, this is a prediction and we want it to be somewhat accurate even though it's not going to go through every single point. So here would be a good fit. These would be a bad fit or not appropriate. And what does that mean when it's not appropriate? It means that we are probably going to have a better model to choose. So for example, instead of a linear, we could choose a logistic, or instead of a exponential, we could choose a linear, or a quadratic versus a cubic, or all of these different things that we will learn about eventually. But right now, you just need to know that random is good for a residual plot, pattern is bad. So even though it doesn't ask, I just want you to think about this. If I go back to my calculator, here's my residual plot from the one we just did with the coffee. It does kind of look like it's forming a pattern here. So I would say that this is probably not the best regression model to choose, and there might be a more appropriate one. There's one more example for you to try on your own, and we will, of course, review all of this tomorrow in class and get to some AP level questions.